All right, let's terraform. All right, so let's get over to the code base. All right, so I'm gonna start off by just seeing where I'm at in the game, and then I'll do some, I guess, math, for lack of a better word, programming, somewhere in between. So one thing I'm trying to do is get the program to tell me how many factories of each type are necessary. So that'll be a start. Wow, it is laggy at this scale. Is it laggy over here? Not really, no. The game's a little hitchy. All right, so thank you. All right, so we're out of reinforced concrete. That's fine. I was actually, there's no reason to feed the city at this time. Basically, feeding the city is just dumping resources down the drain. And that's fine for the oxygen. Oh my god. How? Oh, we get a little over 50%. I'm just like looking at it being like, how many freaking wait a second. Oh, okay, yeah. Well, anyway. Yeah, so we'll keep shipping reconcrete over here until we're out of sulfur, which will be 1 year. Okay, so one of the goals of this playthrough is going to be cityscaping. I'm not really sure what to call it, but basically one thing we're going to do is we're just going to extend the city all the way to the pole, because we want to be able to have factories on site, and we're gonna basically be doing that everywhere. And then I'm not gonna get the final achievement. I don't know how many temperature related achievements there are, but I'm only gonna hit this 1 degree if I have to. And that means that the next thing to make is actually greenhouse gas generators, and that actually doesn't require any sort of planning. So what I'm going to do is we're just going to on-site build infrastructure for polymer bars to turn into or rather, okay, wait, I'm trying to make high speed, or I keep calling them high speed parts. I am trying to make these high-tech parts, and then I think that the machine I want to make in the assembler, the atmospheric extractor. Oh, no. I want a greenhouse gas generator. Okay. Come in.
Your bread is in the oven, so if you hear it go off, it's
Nice.
done.
Awesome, thank you. Okay, yeah, and that requires steel and high-tech parts. So we'll import the steel, which is done up here. Yeah, this will be, well, let's see. Yeah, we'll just convert these over to greenhouse gas generators. Okay. And then we'll restore the steel line. And we'll also make high-tech parts on site. So high-tech parts are 2 aluminum, 1 polymer, I believe. So that will be, we'll set up something like this. So we'll just make that on site over here. So we'll just make like 5 or something, and that'll turn into that'll go into a factory, and we're going to be taking so this factory takes 3 to 1 and 30 to 1. So this is 36. I think this is an optimal ratio. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 8 to 1 is the right ratio. Okay. 1, 2, 3, 4, 5, 6, 7, 8 to 1. And then we'll make a pad 4 polymer. And then, oh right, we're also going to be making high-tech parts. So high-tech parts, nope, high-tech parts. And then we're going to have high-tech parts and steel. So I think what we actually want is these to be over here, but then this needs to be able to hop to here. Okay. And this takes 30 a minute, and this takes fucking 90. Okay. Yeah, so we will never exhaust one of these things. Nope. High-tech parts. Okay, and then I will move some steel bars over to here, and then the last component that we're gonna need will be the steel. Okay, so let's make I'm very confused about this. How do we have enough polymer? We need 90 polymer a year. Okay. Oh, well. Shit. What the hell? When I clone this and paste it on top of itself, it doesn't work. Okay, yeah, so we are satisfying it? Oh. Okay, that makes more sense. That's really counterintuitive. So this is the number of output parts entirely. There's no reason for this to show ×3. It doesn't consume multiples. Oh, does that mean that the speed multiplier... Now the annual production... Oh my god, wait. Okay, so annual production isn't the speed modifier. The speed modifier is still necessary. Although... the speed modifier might not be necessary. But, we already have it, so... But it's confusing, actually, so... well, it's sort of how the game communicates. So... Okay, so, well, let's just take a look at our high-tech parts. Okay, so... It's just this. This is the difference. So it's a building that makes 30 per minute, and that's the only difference. So we're still taking in 2 aluminum bars 30 times a minute and 1 polymer bar 30 times a minute. Oh right, I was gonna make a factory pattern here. So in the declaration resource tuple, so actually in definitions I'll say const rt equals So this is the type of resource tuple. RT type of resource tuple, return new resource tuple. Oh right, and that this has to be an input. Okay, so in type of is not allowed in. How about if I do it here? Resource tuple implicitly has an any type. Expression expected. Oh, right. Wait. Const RT is equal to. Yeah, so I don't want it to be an anonymous function. Okay, in should work. I'm so confused. What the hell? Node const x equals in console.log in. What? Oh my gosh. Okay. What is wrong with me? How do I declare an arrow notation function? I mean, do I even use arrow notation in this project? No. Oh, wait, what? I'm so fucked up. An argument for number was expected. Do I need it to be destructured? No, because you can't. So E and then E dot resource E dot number. Okay, and then we'll, except for new resource tuple. Expected one argument but got two. Ah, I see. It's a type, but it's not a namespace. Okay. Let's see. Okay, so E has to be a string, and let's see. Okay, so oh yeah, resource has to be a resource. Huh. Okay, so string, I guess. Yes, these are okay. These are strings. Resource number. No. Okay. Okay, not sure that it's easier to understand, but it's more compact. I think it needed to be more compact. Yeah, so if we control this TS node, okay. Code, Terraform. Oh yeah, something I wanted to do today as well. Let's see how long it takes to actually start. Finished. Compiling. Program begin. Okay. Okay, so it's all compilation time. All right, so that's nice. Yeah, so we're back to, so we're making parts. Yeah, so let's make, yeah, so this type of balancing work is something that I'll need later. Okay, so mechanical parts, we need 3 per 1. We're making 30, so we're making 90 of these per minute, so we need 180 high-tech parts. Sorry, we need 180 mechanical parts, and mechanical parts are 1 for 1 steel. So we need, let's see, nope, not assemblers, factories. Okay, so mechanical parts. So if we need 180, then we need 1, 2, 3, 4, 5, 6 times 3 is 18. And then we need 6 steel factories. And these take 3 iron each. So if we have 6 of these, then we need how many per? So 2 to reach this 30, and then 3 times 2. So we need 6 per factory. So we need 36 extractors. So I don't actually want to make that many. So let's cut all of this production in a third. Let's make 12. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And then this reaches most of them, and then this will reach the rest. And then we'll jump here. We'll move these over here. And then we'll make a pad for steel. And then we will make a pad for mechanical parts. And this is capable of 180. I don't want to deal with that. Ah, interesting. Okay. Alright, so these should be fully saturated, which is nice. And then that means that we can... so we're consuming... So it's the steel that's the easy multiple. So 60 steel bars. No, high-tech parts are the easy one, but... so it's 20 mechanical parts effectively. Which is just about right here. Huh. Right, we are overproducing mechanical parts. Well, why don't we give a higher production target a try? So let's double. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 11, 10, 11, 10, 11, 12. Okay. Okay, so this is a little easier to build once you're sort of in the swing of things. So if we build 2 more, then we build 12 more. We'll make an extra row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we'll build out this way. And here, and then that means that we need 2 more in total. So this should be 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, everything's working out. Okay, so these are out of range, but these ones aren't. So I think we might need 2 of these to get full transport speed. Oh, okay. And then this one simply cannot reach here. I'm just going to allow myself this convenience. Okay, and are any of these bottlenecked? This one's full because this pad is too far. Okay, so I'll allow that convenience as well. So this could handle significantly higher throughput, but I'm not willing to put in the work. Okay, so yeah, these are now producing enough to supply 4 of these. Is 48 is like almost exactly right. Oh, whoops. Okay, so these take high-tech parts and this. So 1, 2. So that's the farthest away from there. So I could go here, but that's disallowed. I can't go here. Okay, so we're gonna have to bring parts across. And then we will need to, no, let's see. This is terribly designed. I guess we'll bring 2 more here. Okay. Oh, well, I really only needed to make like 10 of these greenhouse generators. How many do we have? 100? Okay, well. I'll leave that there. All right, and the greenhouse generators take fluorite and this stuff, whatever it's called. Okay, so they take in fluorite and sulfur. So we're gonna raise it by precisely the max amount. All right, so we can use one setup that I've used before. So this, where is it? This. Okay, yeah, that's pretty clever. I like that. Okay, so transport on the outside. Or, yeah, jump points on the inside. Okay. This actually isn't the highest density way to do it. I'm going to create a mock-up. Okay. Fluorite. And then this one's going to be sulfur. And let's build all of them that are within a 2-block radius. So that one's valid, then these 2 are valid. And I think that's all. Yeah. So we can we'll have a tiny little road. I like the idea of this. Okay, so that'll be for the fluorite, which means that the fluorite's here and the sulfur is here. And then we will have a road here to here. Yeah, because I'm gonna need a loader too. It's gonna be fun to build this. Okay, anyway, so this is 30. 1, 2, 3, 4, 5, 6, 7. Oh my god. 5, 10, 12 times 30 is 360. So 360 is going to be this, or no, so 360 over 30. 360 over 3 is 120. I just got there. And then over 10 is 12. So we'll need 24 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Not quite 24. Okay. So we'll have a pad here, but that can reach the output. So we'll have a pad here, fluorite, here, 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 there. Okay. So the only one that we don't get is in the center. And then we'll just see how this whole system works. So, destination here, fluorite, 300 and, okay, 350. Okay, cool. And we'll see how many of these trucks can actually be serviced. This is very interesting. Okay. So these are supposed to be getting picked up, but they can't. Okay, so basically one of these pads has lower than 360 input speed. I don't know what the actual input speed is. But yeah, it's lower than this. Okay, so, and then again, we just need 24 miners. So for this one, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. And then we will make one of these jump pads, put it here. Okay, and then which ones are not in range of a pad? I'm going to be lazy. Okay, and then destination, sulfur. Okay, 389, and this one's 419. Okay, I've got. Oh, I can't really take my break right now, considering how fast the temperature rises. Okay, I'm gonna slow this down when we get towards the end. Okay. Shit. I don't want any more than absolutely necessary. Okay. Alright. Put that on pause. Alright, what's our next goal? Reach a population of 1,000 in your biggest city. And this will give us rails. Okay. So we need very, very few of the parts that I just made. So these don't need to exist. Alright, we will need high-tech parts, and we will need them on site. So something that I need to do is ship reinforced concrete, start shipping reinforced concrete again. So we'll need at least 180, and that'll give us access to rails. So we'll only need to support it for as long as it takes us to start getting rails. So I'm just gonna pause. And do we have any water? Okay, thank God. Okay, so there's no water yet. Okay, let's also take apart this infrastructure. Alright, good. A very different approach to this game. It's this time around. Oh. Oh no, how many fucking supply centers did I make? Only 100. Okay. 191 sulfur. What's something we can make out of sulfur that we'll actually want? Oh, we already have the bonuses. Okay, so I don't need to ship reinforced concrete over there at all. What's something that takes concrete that I actually want to build? Okay, rail takes concrete. Okay, so I'll turn this last bit into concrete. I guess I'll just be deleting it though, probably. Yeah, let me just get rid of it. Sulfur 6, 190. One is 15 times. Okay, so it's 6 times 3. Yeah, 6 times 30, so it's 12 times. Jesus Christ, what the fuck am I trying to figure out? Okay. I don't need to figure out, I just need to figure out the number of pads that I need. So it's 190 over 40. And 4 times 4 is 16. 5 times 4 is 200. Okay, so this'll drain itself out. Okay, fantastic. Okay, let's get rid of this and this. Fantastic. Things are looking clean. All right, that's our little splotch. Don't need that. Don't need that. Default view. Okay. Very cool. I think I checked this before but trying to see how many tiles New Tokyo is from the South Pole versus how many tiles New Baghdad is from the North Pole. We could do how many screens it is. So here's the center. So from top to bottom, that's one screen. Let's just put a building we can put anywhere. 2 screen. 3 screen. 4 screen. 5 screen. So it's probably 6 to the actual ace. Okay, and then New Tokyo. Okay, so this will be 1, 2, 3, 4, 5. Okay, so New Tokyo is actually closer. So I think I will actually make New Tokyo my main city. I've also got a lot of aluminum close by. Aluminum, iron, and tons of mountains, which I think is pretty sweet. Okay, so we should create some rail. So first off, let's clear all this out. Is there a way? No, since we're not even consuming this, there's no way to empty those belts. Yeah, so this is whatever. This will happen. Okay, let's knock it all down. Yeah, this can stay here until we're done. Something I could have done is this. So that would have allowed me to drain a little bit more out of these, but not too much more. Okay. 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 And okay. Delete. Okay, so we'll never need buses or trucks again once we set up this infrastructure over in the south. Okay. That's a template. Don't need it. It's kind of a cool template, but I'll figure out how it was done and do it again some other time. Alright, so we've already fed this city, so there's no reason to kill it. But all that we need to do is supply it with oxygen at its requested rate, which is 74. So that's going to be 12 times 5 is 6. 60, so 7 of these will produce more than necessary. Perfect. Okay, so the 1,000 pop city can be maintained by just oxygen. Very cool. Okay, so time for New Tokyo. So one thing I'm noticing is that we don't have that much concrete, but we only need concrete to build. I think we're going to basically convert all of the concrete into rail. And then we won't need concrete for a long time. I guess what we're going to do is convert it into rail, and then we'll need it we'll need concrete to feed this city until it is okay, well, let's get rail first. So we will need to feed that city. So actually, I don't want this infrastructure anywhere near our city. So what we need is steel bars and concrete. So that's very interesting. The trains are what cost high-tech parts, right? Let's see. Nope. It is an assembler. Okay. Okay. High-tech parts and mechanical parts. So it's a lot of steel and aluminum. So let's find steel and aluminum somewhere to make trains. Okay, we basically just want a steel and an aluminum that are right next to each other to make trains. So that's the closest steel and aluminum to each other that I've seen so far. That's pretty close. So that's minus 42, 200, minus 40, whatever, minus 4,200. This one's the closest that I've seen. And that's at minus, whatever, minus 50, 80. Okay. Minus 50, 80. Okay. So this will be making trains, and then the other one will be making, or somewhere with steel and concrete, will be making rail. All right. Getting bread. Stop. All right. So 4 mechanical parts and 4 high-tech parts. And high-tech parts are polymer. So yeah, high-tech parts are aluminum. Okay, so this is where my calculator working would be great. Okay. Train, let's call it train, and then train is a building. I mean, technically it's not a building, okay, but it's a output only. Okay, build a train, and we're taking high-tech parts. What are we taking? Nope. Assembler. Train. Okay. 12 trains, and that takes 4 by 4. Oh, and it's mechanical parts and high-tech parts. Okay. Mechanical parts. And both of these are 4. It's a 12, and then we're making a train. Okay. And then, okay, so I want to make a calculate function that does more than just read the tree. Okay, so my read tree, so read tree can do sort of what I want it to do. I'm trying to figure out if stuff is being passed by reference or not. Let's see. Or like to what extent things are being passed by reference.
Yeah, I'm inviting another mage, unfortunately.
So I think okay, so the first thing that I need to do is make a function that at least annotates the tree. So basically, we may need a first pass. So interestingly, a recipe could pre-calculate these fields. So like a recipe could have calculate how many things need to be put into it and out of it from the get-go, so that this speed factor doesn't need to be taken into account by higher order things. So what I'm actually gonna do, and I think this will work. So a recipe is going to have all of these types, but it's going to lose speed, or rather the constructor will take a speed, but it will have an additional parameter that's not used anywhere else. No, it's not going to. It's just going to take the speed in, but it's also going to calculate something about its outputs. So, so this dot, okay, so it's already going to have this. So, calculate, or simplify resource rates. Function is just not equal to anything. Unexpected. So this is just defining the name. How do I make a class in or a function in a class? Make function in class JS. Constructor. Oh, is it because function is implicit here? No. Oh my god, it's because I just didn't. Is this it? Method or access or property was expected. Return X or return 1. Unexpected token. Okay, a method was expected. So is this a method? Getter. Oh, so methods are just methods just don't have constructor, or sorry, they don't use the class keyword, or sorry, the function keyword. And then I'm assuming that I can do arrow notation like that. Okay, yeah, interesting. That's pretty neat, I guess. Simplify resource rates. We'll do inputs dot map. Oh, that's so nice. Okay. Inputs dot map, and then and for each input we're going to say resource tuple. So map rt, and then rt dot number times equals speed, or this dot speed. Will it? Yep. Oh my god, this is such a nice little experience. Okay, and then we do the same for outputs. I almost feel as though there's a way to... Yeah, this can be a function that we call. So for this, const f equals rt. Okay, so resource tuple. Okay, and then dot map. And then you put the function. So f is equal to all of this. Can I literally just do that? Okay. So I think this will be apparent in my calculation because these numbers will be much bigger. Oh, so, and then we go to the declaration and we say in the constructor inputs, output, oh, blah, 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 all that stuff, and then simplify resource rates. Okay, so these should be huge now. Yes, okay. So we don't have a scalar, so we won't need any of this, but we will need a scalar. Okay, and then this should just equal 60, 30, 20. Interesting. I must still multiply. Where am I multiplying stuff? Very interesting. Where am I passing in this scalar? Read tree. And then this scalar is, well, if anything, we'd be multiplying by the scalar value. Oh, actually, that's sort of interesting. So make high-tech parts is asking for 60 aluminum bars in. So I think okay, so something else that I'm realizing. Okay, well this is like super fucking wrong. Yeah, this is all complete nonsense. Read tree, we're not gonna have scalars. We're not gonna have this. But something I'm noticing here, oh my god, read tree. Okay, first of all, let's get rid of this. Something I've noticed is that, oh no, I do have the bottom on smelt polymer. So I have carbon and aluminum ore, and then aluminum bars and polymer bars. And then okay. Okay, so the descendants already exist in this tree. So something I'm going to do is, if the length is equal to 0, so if we have no descendants, then parent.recipe. Okay, so this is not parents. This is cur node. Okay. Kernode.descendants.length is 0, then kernode.recipe.inputs.map. We are coming from the top, so inputs are actually the bottom, and then we have inputs and then outputs are at the top of the graph or of the node, and then the parents take our outputs as inputs. So, no, I did just notice something. We don't have mining as part of these. We have smelting. But yeah, we don't have mining. Okay. I want to fix that. Tree from resource. Basically, we have a problem here. Okay, so yeah, my way of thinking about this is bad. Okay, so cur node. So this is going to be child node. And parent is going to be cur node. And I think that'll help me understand what's going on a little better. Okay, so to populate the tree, we map. Okay, so wait. So to populate the tree, yeah. So we have this little extra complication of the fact that recipes recipes that have a little bit of a tree-like structure themselves. So for every input, so yeah, we find the output, and then for every input, we are mapping the resource tuple, and then we're saying if the resource tuple resource is none, sorry, if it's not none, so the input is not none, then we do all this work. Otherwise, we return the node. So, okay, so this behavior is slightly wrong. So we want new, so basically we want to push the current recipe to the descendants before we return the current node. And I'd sort of like to return nothing. But no, it could be or null, right? Oh, it's mad because it's possibly null. Well, I mean, I can just do this, like an option chain it. So yeah, so we have this same function except, oh, this is actually strange. Okay. So is a tree node just a wrapper around a recipe? Yeah, so, okay. Kern node dot descendants dot push new tree node. So this kern node has, no, this, this would be pushing itself to, is parent the way to look at this? Because this feels insane. This is saying push yourself to, I don't like this. I don't think, yeah, okay, yep. Okay, well, at least we're getting to extraction. Interestingly, we are not falling apart in the construction of the tree. That leads me to believe that there's just something wrong in our read tree. So if kernode descendants length is not equal to 0, then we console log in recipe name, rname, rt.number, and for some reason we just keep being in this loop. Dot descendants dot length. Yeah, what on earth is going on here? Okay, I have to understand for myself what is actually going on here. So if the current node recipe inputs, okay, so we're mapping onto the current node's recipe. Okay, right, so we're finding the recipe. So we're making a new resource that finds the recipe based on the resource tuple.resource. So we get this tree node back into the function, basically. So we're pushing it, then we're returning populate tree child node. So we get the node back in, and then we really want kernode.parent.descendants.push. No, because it gets pushed on, right? So child node is new, find recipe reverse for resource tuple resource. So somehow this change is actually working, but it's not what I would expect. Or null, and then parent. Wait a second, what the shit? I don't want this in read tree, I want it in populate tree. Okay, parent option, optional chain, yeah, option chain. Okay, or null, return null. Okay, so this should not Stack Overflow. I am confused about this part though, so I will console, oh my god, sol.log cur node. Why? Before its declaration? Oh yeah, parent. And then, oh my gosh, console.log. .log cur node. Okay. So I'm going to parent shot or cur node. Okay. Oh, well, there'll be no spaces there. Okay. So, high-tech parts comes in. I guess it's okay that these are sort of hidden. Okay, so the first step that we make is high-tech parts, and that's created here with the tree node create primary recipe. In fact, that may be what we're actually printing here. Console log root. Root, make high-tech parts. Okay, root, make high-tech parts. And then we get into the tree. Or we get into populating the tree. So the first step, we input stop map. These two, which are, whatever, it doesn't matter. Okay. So those are aluminum bar and mechanical parts. And then we're mapping to, so we're printing out the parent, and then we're making a new tree node, finding the recipe reverse for these, for the resource tuple.resource. So in this case, we're going to be finding aluminum bar. Oh my god, we're going so far all at once. Okay, so this has, so the inputs are aluminum bar and aluminum ore, or sorry, and Jesus Christ, mechanical parts. So mechanical, we're going to find aluminum bar first. So that recipe is smelt aluminum. And then the next, okay, and then we're in here with, so the map. Okay, so we're going through one map first. But interestingly, we seem to be going down this tree. Okay, yeah, so here, extract aluminum is in the tree, and then we get to make high-tech parts, which requires smelt polymer, and then smelt polymer uses extract carbon, and then we're back to make high-tech part. Oh, whoa. Wait, I think high-tech parts are just less complicated than I thought. Yeah, they don't take mechanical parts. Okay, so we do have all of the parts that I would expect. So the tree parent.descendants.push cur node. Okay, so this should be renamed cur node. I know that I've done this a million times. And then this is going to be child. Okay. I guess I'll just change this to cur. That looks bad. Node. Okay. We'll just call it node. And then we have child. We'll call this child node. Child node. Okay. So this is all good. So actually the read tree function is just bad. So parent.descendants.length, if it's not equal to 0, then we input.map something and then read tree. This is killing me. Okay, so let's just make another function. Read tree 2. Okay, and I'm going to get out of there. So all of this is in an if statement. Okay, so if parent.descendants.length is not 0, then we do all this shit. Yeah, it's because of the same thing. So we don't actually, the read tree is not based on parent, it's node. And then, yeah, we don't have child nodes. So if it doesn't have any children, then, okay, so function print node tree node console.log. Okay, so we're gonna map. So we're gonna console.log node, and then we're also going to how can I expand options for like the depth of objects? Because I think if I console logged a resource tuple, it would work. Mdn console dot log depth. Okay, that makes sense. Okay, and then just node.recipe dot inputs dot map Okay, and then there's function, PRT, RT, resource, tuple, console.log, RT. Okay, so node.recipe.inputs.map, PRT, and outputs .map PRT, and then for each node, console log all this shit. So instead, we're gonna print node. So actually we want to print the node, and that's it. Okay. And then I guess what I want to do is console log inputs. So actually I want to do outputs first. Console.log inputs. I gotta give myself a break because this is complicated and it's also kind of neat. Console log RT. Okay, and then populate tree. Let's get rid of these console logs. Okay. Man, that's and then console.log. Huh. Whoa. What on earth? Root make. Okay, hold on. So Jesus. Console.log. Okay. Finish compiling, program begin, that's fine. Else pass. Or no, it's really just else nothing. Oh, there doesn't have to be an else. Okay. Okay. Did I get rid of read tree? Ha! Real heads now. I did not start a focus session. Nah. Okay, so tree node recipe is make high-tech parts. It outputs 90 high-tech parts and it inputs aluminum bar and polymer bar. So the next one that we should see should have to do with creating aluminum bars. So that's smelt aluminum. Outputs are aluminum bar 30, inputs are aluminum ore 60. That's right. And then extract aluminum is the bottom. So its outputs are aluminum ore, and its inputs are none. So something I'm going to do here is node recipe inputs map PRT. So PRT prints console log RT. So what I'm going to say is if RT dot resource is not equal to none. Then we console log. Nope. Good enough. Okay. CLS. Okay. So there's no inputs. That's okay. So there's no inputs on these extract recipes. Good. Okay. Okay. So we don't need this. I am going to... Okay, so I'm going to rename this. Read tree 2. Let's call it read tree. Can you imagine? Okay. So we're going to read the tree. So that's just good tree reading to start with. Let's try the most complicated one that we have so far, which is train. Oops. Okay. So train, the inputs are high-tech parts and mechanical parts. So high-tech parts are aluminum bars and polymer bars. Aluminum bar, aluminum ore, nothing. Polymer bar, carbon. Then we have, so this is depth first. So reinforced concrete. Wait a second. Trains require reinforced concrete? Whoa, hold on. This is news to me. Mechanical parts. I love how many years this has been. So mechanical parts, hold on. I think that I just have a recipe messed up. Let's see. Christ almighty, which is the factory? Okay, factory, mechanical parts. Yeah, steel bar. Okay. Nope. Okay. Oh, that actually does work. Okay. Resource definitions. So it's going to be a recipe definition. So we need to find, make reinforced concrete. Yes. Okay. So these must be Okay, make mechanical parts. Make reinforced concrete. I see. Make reinforced concrete takes in 1 steel bar and 1 concrete. R dot concrete 1. Recipe, inputs, speed, outputs. Okay. I kind of want to refactor this so that the speed is the last number. It's like in out speed. But that's okay. All right, so wow, that would make this so much more complicated. Make high-tech parts. All right, so we'll just move from here. Okay, clear. It's cool. Oh. Whoa. Oh, mechanical parts is... Wait, what the fuck? Oh, it just have this the opposite way. Okay, this is make mechanical parts. Steel bar turns into mechanical parts. Okay. All right. Wow. This is still complicated. Train, high-tech parts. Takes 48. Okay, that's good. That's already nicer than the original readout. So we have to make high-tech parts. So that's the aluminum, polymer, which requires, yeah, that. And then making mechanical parts, which requires steel, which requires iron, which requires extraction. Okay. Now for the calculate. Maybe I'll just... I can't decide if I want to just play or maybe fuck around. No, let's find out the number of parts that we need. Okay, so read tree. How would I find out the number of outputs that something needs? Okay, so I'm going to annotate the tree. And to do that, we won't print the node anymore. So for each of these, oh, I'm gonna get to do a math.ceiling. All right. So we need data from the parent for this. Or do we need the data from the parent? Okay, so let's find an example. Okay, smelt steel. So this is a perfect example. So we are printing out a tree node and we do not have access to the parent node's resource. So the first thing that we need to do is get parent nodes. So a node should know, or a node should know about parents. Okay, so Parent. Yeah, so it has one parent and multiple descendants. Okay, so parents are tree nodes. And has no initializer. That's fine. Okay, so when we construct a tree node, we can I'm gonna get rid of rank for now, and I'm going to say parent. So parent is going to be tree node or null. And then I'm going to say parent tree node equals null. Null is not assignable to type tree node. Oh, just parent equals null. Recipe. Why do I need any of this shit? What? Because it's implicitly any type? I guess I'm not assigning it to either of these guys, so parent, oh my god. I gotta spell well enough. Okay, this dot parent equals parent. Okay, and then in resource step, no, calculate. Okay, so create tree from resource, populate tree. Okay, so anytime we make a child node and then we parent equals node. Argument of type tree node is not assignable to parameter of type. Node is a tree node. Oh my god, kill me. So it's just parent here. Or no, it's just node. Okay, so you're telling me it's not. Why does it think that... Okay, hold on. Descendants, so recipe... So descendants is none. Okay. So I need the name for when I make keyword arguments. I think it's just this. Fuck me, man. Let me chat GPT this. How do I pass multiple keyword args in TypeScript? An object literal as the argument. That's interesting. Takes a single argument of type myArgs, which is an object literal. MyArgs arg1 string arg2. Okay, so that requires the function to take an object. My question is, can I put everything in there? My function, args, my args. So it's R of args type. Oh my god, so this is interface tree or node args. Recipe. Tree node. This is funny. Okay, so these are so the recipe is a recipe. Descendants is a tree node array. Jesus fucking Christ. And parent is a tree node or Jesus Christ pipe null. Okay, and then this constructor will take node args of type node args. I mean, equals node args dot recipe or node args, yeah, dot recipe. I can't see myself wanting to set the descendants in the fucking arguments. Like, it should be equal to the args. It just should have a default. Oh, so I want, okay. Right, so how do I do this with defaults? How do I set defaults for these quargs? Oh, God. My args equals, oh my god, this is like the most convoluted struct. Okay, constructor, and this is all within, yes, this is all within the parens, is equal to this object where, okay. Please tell me at least. Okay, good. Okay, so recipe is recipe has no default. I mean, I guess I don't want there to be a default here, but I guess all of them need defaults. Can some of the defaults, or can some of the quargs not have defaults. Okay, so these are optional. Okay, great. So you can have optional parameters that don't have args. Okay, so descendants. But this is the way that recipe is sent in, so it can't. Yeah, that's the only one that I can't have be, can the non-optional parameter have no default? All required parameters must be defined in the signature and do not have default. If you want to make a parameter optional, you can add it add the question mark. Required arg string optional arg. Okay, so I need to create a default. So if I'm going to have default values, I must have a default value for the recipe. So I can either have no default values, so the default value for the parent will actually be undefined. And then, but they're positional args. Yeah, okay, so it'll just be recipe null. Null is not assignable to type recipe. And then descendants. And parent will be null. This dot descendants equals. Yeah, that's okay. So what's wrong with this? Tree node or null, parent tree node or null, recipe parent. Right. Oh my god, and I'd want to destructure it. Okay, can I do this? This dot recipe. This dot descendants. This dot parent equal. Why can't I destructure args? I am coding this too hard. Yeah, so args doesn't have an iterator. How to destructure arguments within a class constructor in TypeScript. Destructuring to extract properties from an object argument in a class constructor. I don't know if that's legal. Or my little brew of TypeScript would certainly complain. Okay, all of this was to get rid of some keyword args. Okay, so one thing is that I don't actually need... Okay. I don't need descendants. In here. Parent descendants. Okay, and then this dot this parent equals what was this like 1 second ago? Null is not assignable to tree node. Null is not assignable to tree node undefined. Parent is declared, but its value is never read. Equals parent. Okay, parameter can't have, that's fair enough. Is it gonna make me do this? I mean, yeah, I don't know how to do this any better. Okay. What was I even doing here? Okay. Equals new tree node. Push child node, etc. Okay, and then okay, so this will still work. All right. So all that was for nothing because the parent information is insufficient anyway. But it wasn't all for naught because I don't want descendants to be initialized. Okay, so let's just rerun. Okay. So okay, so each tree node is going to get a multiplier. And then it will pass the multiplier to its child. Okay, so scalar integer. Can I say integer? Let me actually just really quick check if I can we'll start with scalar number and then recipe. So we're constructing it with just a recipe and descendants. So we'll actually be scalar number. This just seems like, oh, this isn't the scalar. So it won't actually need, so it will have a scalar. So no, so we need like the parent expects it's the output needed for parent. So parent requires this number. Okay, and then scalar is also going to be a number. All right, so parent requires will get passed in. And then this recipe, this dependence, this dot parent requires equals parent requires this dot scalar equals 1. Okay, and then function sorry, I'm like getting a little messed up. Okay, so each will have they'll have individual scalars and then there'll be a cumulative scalar. So form calc num recipes. Num factories number. I'm just gonna say num recipes, and then the num recipes. This dot num recipes. Is this actually okay? Equals 1. Okay, so those are all the defaults, and then function calc okay. Function init node is going to take in a tree node, or a node, tree node, and then so node dot scalar, or node dot num recipes is equal to, okay, so let me just do const float num recipes. Actually, let's just do this all with floats for now. Okay, node.num recipes is equal to node.parent requires divided by node.recipe.outputs 0 dot number. Oh yeah, wait, what is the oh, the recipe is already being scaled. Okay, great. So node.num recipes is that. Then I guess scalar is going to be equal to something else later, but constructor and then init node self this. Function implementation is missing, or what did I do here? Oh, it's because of this shit? Simplify rates. What about this? I mean, technically we don't need any of that because it's technically this. I am confused. Export class tree node, all this, and then init node. What fucking overload is there? Function implementation is missing. What about this? New node or whatever. Fun. Oh my fucking god. Object is possibly undefined. What? What? Oh my god. Okay, and then init. Oh, right. Yeah. Init node. cake. Okay. New tree node, all this shit, and then we're inside a resource tuple resource. Resource tuple dot number. Okay, and then our print function, our print node is going to log node, and then, so I actually, before it does nodes, I wanted to console.log requires, or parent requires whatever. Okay, so parent requires items, and then node dot parent requires. And then when we print the node, it'll have the other data that I want. Parent requires 90 items. Hey, look at that. We need 6 for the smelt steel. Parent requires 30 items. Smelt steel. Oh, whoa. Does it... Why are the descendants suddenly printing? So descendants is... Hold on. Okay, so I don't want it to print descendants, so I guess console.log node isn't gonna work anymore. Or I guess I can ask how do I format strings to have colors in console.log? Okay, well, num recipes is 1. Okay, num recipes is 1.6. Num recipes is 7.5. Okay, great. This is fine. This is pretty cool. I didn't know that. Is this actually true? Let's see, node. Huh. Nice. I didn't actually know that. And then there'll be just a library that does that for me. Alright, I'm gonna take a little break. Alright, we are actually not far from what I originally wanted. So let us also pass the scalar to the children. So when we're making a new tree node, we will also pass the scalar which is a number. And can we pass a default value? Okay. So scalar is equal to scalar. All right, so scalar is going to need to be recalculated for every child. So if we go and we take a look at here. Okay, so populating the tree, wait a second, do I have a fucking other, where am I passing resource tuple.number? Okay, that is in populate tree. Okay. So, and then scalar I'm going to say that we pass. So if I pass the scalar from this node to the next one, that is what we want. Okay, so node.scalar. And then in declarations, okay, so in init node, this .num recipes is equal to all of that shit, and then this dot scalar is equal to, or this dot recipe dot output number times scalar. This dot scalar. And then this dot scalar so we're going to recalculate scalar after we so theoretically this should be 2 values, but yeah, I don't actually want this. So I want so we have an internal scalar. Okay. Okay, and then internal scalar is going to be 1 dot internal equals 1. Okay, so this dot scalar is a pass through. So this dot internal scalar equals this dot scalar. This dot scalar equals this dot num recipes time, or it's just times equals. Okay. Let's try this on something very simple. So let's do steel bar. Okay. Okay, so steel bar calls smelt steel. Parent requires 100. So we okay. Whoa. We are already too advanced for this. Okay. Or we're doing too advanced of a thing. Okay, internal scalar is 1, scalar is 1. And then, so we need to, so hold on. So we're getting, did I do steel bar? Okay. And then, so yeah, we need iron ore. So the parent requires 90 items. And the internal scalar should be 1, and the scalar that gets passed to future generations should be 6. Okay, so now let's do I guess mechanical parts. CLS, CLS. Okay. Make mechanical parts. I want 30 num recipes, internal scalar 1, etc., etc. Okay, I'm also gonna parent requires how many this is such jank. Hold on. How do I reset the value to default in the middle of a string? Okay. So declarations. Nope. Nope, nope, nope. Okay. It's this ridiculous one. Parent requires green. Okay. Nice. Okay. Great. Okay, so there's only one real behavior left that I want to create, which is I want an internal number of machines. Basically, I just want... Yeah, okay. I just realized that all that we need is to round up the output number when we ask for how many things to... Oh my god, whatever. Anyway. Okay, so... Okay, so now we're just going to have a... So we don't actually... Yeah, so we want... function. And then I guess I just want like print simple print node basics, takes in a node, type tree node, and what we're gonna do, console dot log node dot recipe dot name actually, okay, hold on, let me take a look at so name smelt steel. Okay, so yeah, we'll want the recipe.name because that's the, okay, so console.log recipe.name console.log outputting okay, so yeah, so we'll need scalar, so this is gonna be shit, node dot parent requires node dot num recipes. Okay, node dot num recipes okay, and then we'll do a rank after this. We'll make the yeah, we'll fuck whatever. We'll make a rank after, and then intabulate based on the number of ranks. Console log recipe name. Okay, so just all of this shit is going to be inside one giant template string. Okay, so node.recipe.name and then I can do for buildings, okay, in needs math dot ceiling actually think internal scalar doesn't need to exist because it's just num recipes. This is the internal scalar. Dot num recipes times node dot recipe dot output zero dot number items. Okay. Okay, print node basic. Okay, and then let's get some colors. Blue. Okay, so and then X1B. Additionally, if you want to format console output with colors and styles in a more robust and cross-platform way, okay, npm chalk okay. Oh, that's hilarious. Okay. npm I chalk. Okay. Chalked out blue. Yeah, okay, cool. All right, blah, 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 blah. Oh, how do I do substrings though? Oh. Right, of course, because it transforms the string. Chalk dot blue. Needs chalk dot green chalk dot I don't know what's some other red, green, blue, yellow. Okay. Oh no. Require of ES module. Chalk ES module. Has changed to ESM. They provided a better understanding to what that means. Yeah, well, I don't want to. This is confusing. Package. Chalk. Okay. I feel like this won't work. It did. Okay. Okay, blah 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 blah. Okay, chalk. What are the colors? Blue bright. There we go. Nice. Okay, I like all this. Okay, and then if I do 55, then what do I do? Okay, and I also want to shit, what is this? It's dot. Oh shit. Okay. Precision float print or log JS. Christ almighty. Okay, and all of this. Dot to fixed to recipe name needs okay. Okay, that's great. Okay, so now let's do train. Oh my god, we've got it. I think the very first calculation is wrong. Let's see. So we need 5 buildings to make 55 items. Make high-tech parts only needs 1 building to make. Okay, so first of all, okay, so that's true. Okay, so if we were going to make 55 trains, we would need, I think, a lot more than this. So we would need 12 times 4 high-tech parts. Or no, 55 times 4. Oh, we're just not carrying the data through somehow. I think it might be to do with Okay, so we're gonna print not basics. So print node. Okay. All right, this is off the screen now for y'all. All right. Okay, so now we can see everything. Okay, num recipes, scalar. Okay, build train. Parent requires 55, so parent requires 55, so the num recipes is 4.5, so that's the scalar. So 4.5 should get passed to the children. Okay, so how has this happened? Resource definitions, declarations. Okay. Tree node. Num recipes. Is gonna be it's this dot parent requires times the scalar divided by that. Okay, so it's the opposite. Okay, print node basics. Oh my fucking god. Okay. This makes more sense to me. Okay, so let's calculator it. 55 times 4 is 220. This is great. Okay, so is this actually right? I feel like this has gotta be wrong, right? 6,779 iron extractors to fuel 5 buildings making trains at once. That's too much. So the first level works. I think this column is where it breaks down. So if we print node again and rerun, I think we'll see the scalar running away too fast. Okay, so the scalar is 4.5. Okay, first of all, I'm changing this to 12. Because then we just need one train building. Okay, so the scalars are different per recipe. That's important. So this is high-tech parts, this is mechanical parts. Both of which need 48. That's correct. Okay, so we need to make 48 of 48 high-tech parts.
Yeah, no, that's right. Because one high-tech part recipe makes 90 high-tech parts. Scalar is 0.5. Parent requires... Sorry, I got distracted. Okay, so... So one of the children needs... I mean, this all seems reasonable.
I just don't know what the flip happened when we had a lot. Okay, so we'll actually be able to tell pretty easily what's going on by if these things grow linearly or not. So print node basics. This seems reasonable. Okay, so let's just follow this up the chain. Okay, so we need 16 extractors to make 230 items. So let's just go up the chain. Calculator. Well, I mean... Okay, so 230 divided by 3. Okay, so we are already messed up. Because we should only be extracting enough iron to provide for smelting steel. And smelt steel is 90 into 30. So maybe let's see. I think I want to retest this with something simple. Or something simpler. Okay. Oh, well, this is just... wrong, right? Num recipes... No, that's right. But this is an impossible... I think this is an impossible number for extract iron. Oh. Let's just, okay, so let's just do a linearization check. So this should require 10 buildings to make 140 items. Yeah, okay. So something has gone quite awry. I think it'll be easy to solve though. So let us print the node. Oh shit. Okay, first of all, okay. So the number of recipes is 4. And the scalar is therefore 4. So let's take a look here. Okay. Okay. So it works correctly on the first pass. It's not working right here though. I think the number of recipes is equal to 4. Jesus Christ. Okay. So what was this past? So this was past parent node requires 120 items, and it was past a scalar of 1. So the num recipes becomes parent requires 120 times 1 divided by, yeah, okay, parent requires times 1 divided by the number of things that this outputs. So this outputs 30, so num recipe should be 4. The scalar should not change yet. The scalar should change. So the scalar should change on initialization, I guess. This is initialization. Parent requires 120, scalar is equal to 1. Okay, so this right here is the problem. In fact, that might be the entire problem. So root is new tree and then populate tree. Inputs.map. No, because this node is made here and then it's given children. So this can all be solved with parent requires. We don't need any of this nonsense, I don't think. Okay. So we don't need a scalar either. So when we pass, that's actually really funny that you're allowed to give that calculate. Okay, so we don't want a scalar. So let's see what goes wrong when we do this. Okay, so yeah, so we're not passing our num recipe sort of shenanigans down the chain. So when we make resource tuple dot number times node dot num recipes, so 120 requires 4, and then there's the parent requires 120 items, not 30. So the number of recipes that we will need is 4. And then the parent requires 360 items from us. Okay, so that, okay, great. So now I can do train, and now we can get rid of print node basics. Also, importantly, let's rename print node to print node verbose, and then change this name to print node, and then not do both. This seems right. Okay. So let's make 12 trains and see if we get so you get 1/10 of everything. Okay, this is very cool. Okay, and now I'm going to give everything a rank. So a tree nodes will have ranks. So we're finally doing this. Rank number, and then the default rank number equals 0. All right, so, and then this dot rank equals rank. All right, and then this should be simple. So when we are building the tree, so populate tree, so here, so the tree node has a rank. So in populate tree, when we create the node, this dot or const new whatever const child rank. No, this is easier than I'm making it seem. Node dot push child node. We need a child node, and then we need this dot or node dot rank +1.
And then when we're now blah blah blah. Okay, so
I'll print a red minus sign. npm print trees.
oh wow. No. Okay. Find tree reverse blah 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 blah. Tree from resource blah blah blah. Print tree verbose. Print node console.log and then oh, whoops. Okay. Dollar blah 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 chalk dot red bright and then minus dot JS string repeat string.prototype.repeat repeat. Okay. And then node dot rank. Come on. This might just fucking work. What? Okay, hold on. I think that is an artifact of resizing. Okay, yeah, and I want it to be a little nicer, but it doesn't need to be. Okay. And then and then that repeat node rank plus that. Oh my gosh. Plus, okay. Plus node rank, then
that else. Aww. Okay, okay, cool. Dot green bright. Okay. Okay, so I am ready to make trains. So we only have one direction right now, but that's pretty good. I'm happy with that so far. Okay, so GS, GS. Okay, so create and upload GH repo from local. Okay, get init. So I think I have a get ignore already. Okay, so G add dot G CM init. Okay, so if we look at the last several commands, then we have our slab doc. Okay, so command line. New get repo from existing code. Get init. I could check if there was a git ignore, not manually, but okay. So that's all good. All right, you couldn't see that I was adding all this stuff, but I was. Okay. The last thing, well, this isn't going to be a command line resource, but yeah, I don't want to figure out how to make this a command line resource. What I should do though, tree from resource, and then I'm going to optionally, well, yeah, tree from resource, okay, optionally have a num desired number target out oh my god, output number. Okay, I'm just gonna require that you say how many you want. Okay, let's make, say 12. Let's make 12. I mean, if we had been making 12 a year, we would have way more than enough now. Okay. Oh, this is so cool. Okay, so making high-tech parts, and then on the other side we're making mechanical parts. Okay, so we actually want this over here, and then here we're making mechanical parts, and we need 2 buildings. And then we'll make a pad for mechanical parts. And we'll make a pad for high-tech parts. And then we need 2 more buildings. So these ones are for steel. Whoa. Trippy. Oh, okay. I was just reading it wrong. Okay. Actually, as much as this, oh, right. And then this is all well and good for here, but yeah, I'm gonna want this. Okay, this. Boop, boop. All right, and this is a steel bar pad. And this will be an iron pad. Okay, so we need 2 steel smelters, to make 48 items, and then we need 10 iron ore extractors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They will not be in range of a single pad. Okay. Will these ever have scarcity because of belt efficiency? It doesn't look like it. I haven't seen them go down yet. Okay, and then we need to... Oh my god, this is so nice. Oh. Okay, so this is going to be for aluminum. So smelt aluminum needs 2 buildings to make 32 items. And we need 5 extractors. 1, 2, 3, 4, 5. And this will be aluminum ore. And then we need 4 extractors and 1 polymer factory. So we'll make our polymer factory here, polymer bar, and then we'll make our carbon factory, and then we will make 1, 2, 3, 4 carbon extractors. Atmospheric extractors. Oh my god, that's so nice. So this should now be running at full tilt. Okay, so what is the holdup? It could be that there is no actual holdup and that it was just like a startup problem. Interesting. So smelt polymer needs 1 building to produce 16 items. These need 48/3. So these should be overproducing. This is assuming that we only need 16 polymer. 32 aluminum, 16 polymer. Let me check my recipes. Okay. Okay, extract aluminum, fluorite. Okay, carbon. 12, we make 1 carbon. Okay, smelt aluminum. Make 1 aluminum bar from 2 ore, and it's at 30. Smelt polymer. We take 3 carbon in, make 1 polymer bar, and 30 out. Huh. Oh, but it's because this factory does not need to be running full time. Oh. So it's really just the train that we care about. And we haven't seen hitching yet here. Or at least I haven't seen hitching yet. This just means that it doesn't currently have enough to build the next recipe, I think. Oh, this is so cool. I never would have balanced this so nicely. Let's restart that. Because if this is... I guess it could overproduce because these are rounding up and then this is rounding up. Yeah, there's no like... There's no way to completely stop the rounding errors. Okay, now let's go and... Oh, that's so fucking sweet. Okay, yeah. So turning this into a graph visualizer and then getting it on the web will be really nice for a lot of people. So I had a place, so I need a iron node right next to a sulfur node now to make my train parts. Okay, here's a combination iron sulfur node. Oh my god, and now this incentivizes adding recipes to here. Okay, so okay, rail is concrete and steel. Rail and rail stop. Concrete and steel. Rail and rail stop, 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 concrete and steel. Rail and rail stop. Rail stop. Right, this does not need to be like that. Okay, so calculate rail. I don't know, like 120, I guess. Ah, I have not made a recipe for them. They're just resource definitions. Rail, or I guess build rail. I mean, it's a fucking name. They don't need to be... They don't need to be all dumb like this. Okay, anyway. I assume that they're 30s. Oh, right, they are different. Okay, so we make 8 and then 96 over 8. We'll find out soon. Node 96 over 8. Okay. So it is actually an 8, but it's making 8 and it's making rail. Oh, this is so cool. Okay, concrete, steel bar 1,
and 1. Built at 12. Build rail. Okay, concrete and steel. It's gonna be this. Okay. Okay, build rail stop. Rail stop. And it's 1. Okay. The only difference here is that it's a rail stop and it's 1. Okay. Let's run it. This one needs 2 buildings to make 120 items. Okay, let's up it. This is 96 times 2. I don't know, 200. Okay, so this is cool. So we have a way to make like these. Well, anyway, okay, so let's make some assemblers. 1 rail, 2, 3, and then we need factories that can smell. This is hilarious. We're going to need to build some of this stuff on the call. So now I can also do something that I never could before. 3, 4, 5, 6, 7, and then we have a sulfur pad, and then we need 7 iron deposit ones. So let's go 1, 2, 3, 4, 5, 6, 7, and we'll go here, here, here. Okay. And then we need a factory. We need 2 factories to smelt steel. And we need 2 factories to smelt concrete. And then we need a pad for both of these. Concrete and steel. And then we need 1, 2, 3 assemblers, which are going to build rail. That's just so neat. Okay, and then rail stop, and let's make 25. I think we're gonna want to make 24. 24. Okay. All right. Let's do it. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and then we're gonna need steel. Yeah, okay, cool. Steel, and that's gonna output to here. And then we need a concrete plant, and that's going to output concrete, and then we're going to
Make rail stops in 2 buildings. And this is so cool. So these deficits are caused by the fact that I'm not asking to create. No, I'm asking to create exactly 12. Oh, that's so sweet. That's so sweet. Okay. So sweet. All right. Let's look at regular view. Okay. New Tokyo. All right. So what is New Tokyo going to want? It's going to want concrete. Okay. I'll actually be right back. Gotta take care of my body, even if it isn't fun. Even if it's more fun to just sit in front of the game for 1,000 hours. Okay. Okay, so let's get you on the right side. You are. Okay. So now we can build a rail. So let's build a... I mean, who cares? Punished for making a reasonable rail system. Okay. Who knows? Okay, so we need 10 concrete. Okay, so concrete. Okay, let's just say we need 100 concrete. Okay. So we need 4 smelters. No. Okay, yes, this is the best part of all of this.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we don't even have... This is so nice to know. Holy shit. Okay, so we don't have quite enough for 100 per right now. But we're kind of close. So I don't have the inverse calculator, but we'll have that at some point. It's not really like a huge deal. Okay, and then we're gonna make 1 concrete, 2, 3, 4, and then those are all gonna be within range of this concrete, and then this is gonna have a destination here for concrete, and then we'll hop concrete over to the storage bin like this. And then we'll just start off by providing oxygen. So if I remember correctly from the other side, it's like oxygen and then atmospheric extractor 1, 2, 3, 4, 5. Oh, we actually can go like this. Yeah. Okay. Easy enough. Okay, so this will start demanding oxygen at some point. Then it'll start demanding reinforced concrete. And then things will get a little more difficult. So we'll want to make reinforced concrete pretty far away, I think. Well, we'll actually see what the numbers are like. Are we seriously we're capped at 999 on the other city? Man, I didn't even check what the throughput is. It's probably very high. Yeah. Okay. So we're gonna need reinforced concrete. So that's why we set this up here. Okay. So reinforced concrete. Let's do, I don't know, 100. Yeah, okay, so this is why it's a headache. Okay, so let's pretend that we're going up to, I don't know, 1,000. So it's 200 buildings at once, and 40, yeah, so that's where things get complicated. Okay, so this is, or I don't know what we need to get to. Let's assume it's 180. So we'll build like that. Okay. Are these asking for reinforced yet? Okay, not yet, but soon. Okay. Oh, that's pretty funny. Okay. So those extractors can stay there, I suppose.
Yeah, I mean, what's the harm? Okay, so we need 36 of these. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9. Shit. Okay. Five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18, and then 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6. Okay. So we'll just hop some sulfur around the edge here. All right. Then we'll make a train stop. Okay, so train is gonna go here, and then we're going to make a little loop. All right. And then we'll drag the trains down to here. Okay, so we'll have concrete coming from multiple places. Okay, so we'll have a concrete stop here, and then we'll have, okay, so 4 of our buildings are here, and then we'll have 2 buildings here. This isn't, it's actually not super clear how to separate this stuff up. But let's just assume this is enough. That's a little less than 100. Okay, concrete. Okay, and then we need 36 extractors. Extractor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, I think. Okay. And then minus 0. Okay. Okay, minus, well, 1, 2, 3, 4, 5, 6. And then, nope. 1, 2, 3, 4, 5, 6. And then minus 1. Okay. And then we will have a 6 factories on site, so these can all serve multiple factories. Steel bar, 1, 2, 3, 4, 5, 6. So there's more than enough, but do we actually have enough? No. Yes. Oh, well, probably only because those are full. Is there an is there a more effective way of yes, is. Okay, that, and then here we have something that can accept. Yes, okay, great. And then we'll have a train line. Okay, train stop. And then since this is 1 and 1 and 1, we actually may as well bring the factory all the way home. Okay. And I suppose we can, we will have a sulfur stop and a sulfur stop, and we will have a steel stop. And then we will make reinforced concrete from there, so we'll actually have our 2 concrete stops. Concrete, and this will unload from both, and this will be our steel. And we'll put it there, and then we need 6 buildings that can make reinforced concrete. So it will be 1, 2, 3, 4, 5, 6. And then we'll have a pad here for reinforced concrete. Now we'll take from all of those and hop into there. So let's set the origin of this to here. Actually, cool. Okay, so this will go destination here, concrete, destination here, concrete, origin here, steel bar. And we wanted to make how much? 180. So we can make a train calculator. That could be cool. 177 is the minimum and 93 is the minimum. Might want 2. Okay. Interesting. Okay. This is insufficient for loading. Okay. And we are saturated on
concrete, but not on steel. So this is our steel stop. How about we move this one here and then move this here and then get rid of that? No, because then that's too far away from there. I suppose this will have to be good enough. So we still don't know the like art slash science of loading and unloading. This pad is not close enough to this guy. So no. So that's not close enough. And that one's not. Okay, so now we are doing a dumb setup that I don't like very much. But at least this is the exact amount that we need for 180. Okay. Unlocked waste disposal and recycle center and metal waste. Now I need to raise the temperature by another 10 degrees. Whew. I don't know how I feel about that. Okay, well, I can stop feeding the cities. What is my current goal? Right, and I have waste disposal, recycle center. What is my population? 1,000. Okay, so I now have multiple cities like this. Yeah, that's fine. You can fall apart. I don't mind. Okay. Yeah, because I don't want to be draining resources from the world when I don't have to. Okay, the temperature's still very comfortable. Let's go back to... Where is it? This seems like a good one if it isn't the one from before. Okay. Greenhouse gas generator. Okay, let's just use the setup we had before, which was slightly less efficient last time. Now that we have trains, it's gonna be great. Oh man. Okay, so let's do sulfur, and then let's do fluorite, and then let's do gas generators 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No. Okay, I think this is it. Okay, great. Okay. So we're gonna go here. Oh, no, no, no. This will work. Okay. Oh, right. And then we need to come around here. Okay, and then we're making train stops. So here and here. And that's not a valid train stop. So we'll do this. Okay. And then, so we need 60, so, oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need 12 times 30. 12 times 30. And then I need sulfur. Sulfur ore. Okay. $24. This is very silly. I am in reality not going to make quite nearly as complex of a rail system. Or whatever. This is not, this is, I'm gonna leave this infrastructure here. Fuck me, man. Okay. I'll leave this infrastructure here for later. But yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20, 21, 23, 24. Okay, well, actually, that's kind of convenient. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24. Okay. And then we have sulfur. Boop. 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 Okay. And then we need no factories because we're just transporting raw material. So we'll do the same here. 1. Alright. 2, 3, 4. We're gonna set this up differently. Okay. And then we're going from here to here. Fluorite. 360. Here to here. Sulfur. 360. You know, ish. Okay, we'll see what the next technology is. I don't mind stalling the city at 2K. So this way I'll know if there are barren patches that we have tried to use the correct amount. Okay. This Yeah, so this is an insufficient way to unload one train. Can you change the perspective view? Options, controls, speed, scroll. Oh, cancel is right click. Select items. Oh, okay. Well, that's cool. Okay. Okay. Oh shit. Oh, okay, good. Okay, and then we better not get any fucking water. I suppose I can add these. Okay, it's concrete 1 and concrete and high speed parts. So recycle center, waste disposal. Okay. Or is it recycling or recycle center? Oh, recycle. Waste disposal. Recycle center, build, waste disposal. They're 12 each, and one is concrete, concrete and concrete and so concrete for waste disposal, right? Yeah, concrete. High-tech parts. Recycle center. Waste disposal. Okay. Alright. Concrete and high-tech parts. Okay, so let's pull from this. Factory. Okay, whatever. Okay, I'll have more of those than I could ever need soon. And then, oh my gosh, speaking of more than I could ever need, how many trains? Okay, 169. Okay. Oh, this is so neat. Okay, I have enough time to mine another couple patches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, two, three, four, 5. Very nice. Okay, we're approaching the max. We're approaching the target. Okay, and wow, it takes a long time. All right, so this is inefficient. Okay, when I get to when I get to 9.8, I'm switching to speed 1. Student speed 2. .90. Okay, this is more than we will ever need. Okay, total population of 3,000. I can do that. So we will need to start manufacturing high-tech parts. I will also need to make some recycle centers. So I will actually change this to recycle center. Okay, and we'll pick up high-speed parts from here. We will drop them off here. High-tech parts. Okay. So we want high-tech parts, and then we want some concrete. That'll be plenty. Ah, it won't. And then we will also need a high-speed parts pad. Okay. Yeah, that's true. This can only reach there. Okay, we now have 9 recycle centers.
Ah. Okay. So let this run for a bit. I'm gonna be right back.
Yeah, that's more recycle centers than we'll ever need. Great, so let's go back down to 0. Let's go to 0, and you can finish off your current work and then pencils down. All right. All right. For what it is worth, I think we actually will need a great deal of trains. All right. So we gotta get a city to 3,000. So one thing that I'm going to do is I'm going to produce high-speed parts or high-tech parts on site. So we're gonna run this, and we're going to, sorry, high-tech parts, and then we're going to make 180. And let's run the numbers. Okay. Totally reasonable. We will also need to initiate some sort of waste disposal. So we're going to, first of all, let's grab you as supply center, and then let us grab a depot for high-tech parts, and then there will be 2 factories that make high-tech parts, and then there will be rail stations coming in. So these high-tech parts require aluminum and polymer. So there will only be aluminum coming in. So there is aluminum bar and polymer bar. Polymer bar. Okay, so these are Mark 1 depots, I believe. Okay. And so we will need 16 extractors. We will need 15 15 polymer buildings. So let us make 2 polymer smelting factories, and then we can make probably more than 1 carbon manufactory. Seems unlikely that we'll be able to, well, we'll start with 1 and then see where it goes. Charbon, and then we will create a atmospheric extractor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
13, 14, 15. All right. Perfect. And then we will bring in aluminum bars. Oh, and that's where the secondary thing is. Smelt aluminum, so we need 120. 60 times 2. Yeah. Okay. All right, and then we'll make a train station, and we will originate from over here. So actually what we want to do, 1, 2, is we need 16 extractors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We do want this for the long term, but I also want to play around. So we need aluminum ore, and that goes into 4 smelters. So 2, 3, 4, 5, 6, 7. And then we will build a smelter here, aluminum bar, and a smelter here, and a smelter here, and a smelter. I actually have decided that I don't want them that far away from each other. A smelter there, and there, and there, and there, and there. And then we will have aluminum bars and aluminum bars, and we'll have our rail station right here. 3 rail, all right, and then here, and then okay, and then the rail will connect with the rest of the railroad. And then we will set the destination to just outside of New Tokyo. Aluminum bar, and we need 120. 140 is the closest that we can get. All right, and now we will re-enable steel bars. So we're gonna go back here and make reinforced concrete 180. This way I can tell how many things to request from these train stops. So we'll need 180 steel, 160, and then the concrete is also 180. Okay. So we already have spaghetti. Okay. And we need... interesting. Okay, so we need 6 buildings. 1, 2, 3, 4, 5, 6. So we do not need this 7th building. And then this is 1, 2, 3, 4, 5, 6. 5 times 12 is 60, so we're at 72 right now. So if we want to double that, then we need, yeah, about 1, 2, 3, 4, 5, 6, 7. So 7 plus 6 is 13. 12 times 12 is 144, plus 12 is 156. 168. 180. All right. All right, so the waste disposal is insufficient. Let us dispose of some waste. So first, there is metal waste. So metal waste becomes 3 to 3, so it is irrelevant where this gets processed. All right. And then this requires a depot for metal waste. And then a small amount of the aluminum from here can be fed into our high-speed parts manufacturing. So let's just do that real quick. Actually, what we can do is sort of we can in place create a sink and then create high speed parts. Okay, so and this will be, let's say, well, we need enough to sink some amount of aluminum, which will be, okay, so it's 60, so let's say it's 120 aluminum. So I need, so this is where our this is where things will start to get a little messier. Okay, 90 is one building. Okay, so I'll need 2 smelters. Okay, perfect. Alright, so one of these requires up to 2 aluminum smelters. So let me create a pad to offload aluminum bars from here. It appears steel bars are going to be a problem, so let me alleviate the steel bar problem by simply creating extractors, which will actually be important in the future. Okay, so we need 2 smelters. So let's go. Okay. Aluminum bar. Okay, and then okay. Population of 10,000. Understood. I can continue this for a little while. So these will take... Oh, I do not need those. Right. So this immediately turns into high-tech parts, and then we need 8 extractors, which will be 1, 2, 3, 4, 5, 6, 7, 8. And then we need to make polymer bar, and then that needs a factory making polymer bars. Okay. Wow. Impressive. Are we... So according to my spreadsheet, even though the polymer bar there is red, we actually have enough. Okay, so this is backing up. So this can sink a lot of aluminum waste. 60 times. Well, it's hard to tell. Okay, so it's saying 60 steel bars, so it's 90 waste. Okay, so this is already more than one of these factories can handle. Okay. So I don't know for sure exactly how much we need, but I know that we can't, I know that we don't have enough supply to, well, no, so we should be alright for now. So we're going to be unable to, so we're importing 180, and we're not even at 180 demand yet. So we are outstripping, so this is 90, 180. Okay, so this is still within 2 hex of everything. Okay, so I'm going to have to slow down this input, and I'm not actually sure what a good way to slow it down is. I cannot disable these buttons. Okay, so a couple of things to look out for. We don't have enough sulfur coming in, meaning that we don't have enough concrete coming in. Okay, so we have stopped short of crisis here. I don't wish to balance this, but I will. Okay, we will always have enough resin. That's not really it's not a reasonable expectation that we're going to run out of resin. Okay, so we're full on aluminum. Okay, so we still do need reinforced concrete though. So let's run the math again. Reinforced concrete 180. Okay. So we need 36 miners. So we have, so here we have basically 0. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so we have a lot, but we don't have enough. This is why this is why concrete is such a pain in the butt. Okay. 6. Okay. So we can load the concrete on fast enough. I think that we cannot unload the concrete fast enough. So we only need 180 to come in from here. Okay, I can, 177 is the minimum amount that I can send. Or attempt to send, I suppose I should rather say. Okay, so I've reached a point of not having a good understanding of what needs done. So does that unload completely? It unloads mostly. Okay, so let's reconfigure this whole thing. Okay, so reinforced concrete is going to come in. So we have concrete and steel. So we need 2 offloading pads. So I'm going to just say concrete and steel. Let's just do the simplest possible thing. And let's say that there's going to be 2 of each. So that won't quite do. Concrete, steel. Okay, so if we have one here and one here. Okay, then we can have, we need six factories that are making reinforced concrete that are within 1 jump of all of these buildings, basically. Okay, so that is that. Trying to figure out which ones are more optimal. So we probably want one
here. And then we want a reinforced concrete pad here. And a supply can be there. And then we'll get rid of that one. Okay. Great. Fantastic. We have run out of high-speed parts. Let me request enough aluminum. So we are still almost exceeding the amount of aluminum that we can produce. So let us increase the number of polymer bars that were, or of, oh, I see. I've committed an error. So I will need to be somewhere in this area. Let's see. Okay, so this is a better area. And then I can simply surround this with a couple of more. So this is overkill in terms of carbon. Let's see. Okay, so as is wont to happen, we are running low on reinforced concrete. And as it so happens, the loading of that concrete appears to be a bottleneck. Alright, so now what I'm going to do is, instead of cramming this station with more trains, I'm going to make another stop for concrete, and that will offload from this one, and then I will onload, I guess. We'll onload here. So we can, you know what? I think it wise to attempt this, and then to freight in some more sulfur. And with the new sulfur line, I think it'll be wise to, let's see. So I don't know, speaking of things that it's wise or unwise to do, I believe this is a better way to handle the output. This is 219 and 30 times 3, 90 times 3, 9 times 3 is 270. Okay, so I'm going to make another 180 loader. So this can theoretically support 180 concrete. So what I'm going to do is come over here to the other side of the city and make a mirror image of this.
that's irrelevant. Okay, and we'll have a resource hub here. Amazing. Where even are, oh, our oxygen, okay. So we're having difficulty moving the oxygen to its destination. And these are somehow outside of the grid. So let's make a second input. Then get rid of some of our skyscrapers. Okay, and as usual, reinforced concrete is a bottleneck. Okay. So we will create another little outpost. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And we go a 1, sulfur, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then minus 1, 2, 3, 1, 2, 3. And then we make factories. So we need 6 factories. 1. I want you to make concrete. 2, 3, 4, 5, 6. This does not have a loader. Okay. And these will all actually be able to offload to here. Correct? Yes. And then we'll make a rail. Okay. And then we will pop on by here. Okay. I actually believe that I want this to go a little further. Alright, we'll make a stop here and here. And we'll make a stop here, and this will be set destination here, and have it be concrete. I suppose this is immaterial, so if this were to be the steel, so let me change the destination to here. Oh, it changes the direction that it goes. That's cute. Okay, and then I will need some more steel. Okay, well there's another reason. So we should be constrained on steel. We're not quite yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, anyway. 1, 2, 3, 4, 5. Alright. Let us rebuild. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6. And we can come here and here and here and here, and then you can come on the outside to begin, and then minus 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, we are set to go, and then we'll create a new stop. Okay, so something else I'm going to do very quickly here is build out this infrastructure. So let's build closer. So 1, 2, 3, 4, 5, 6. And 1, 2. I think 2 will be enough. And then I will make a stop here, and then we will change the origin to here. All right, and then I will build another station starting on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6. And then we'll grab this and we'll say, okay, so 0, minus 0 so far. Okay, and then minus 1, 2, 3, 1, 2, 3. All right, and then let's copy a little bit of this design. So 1, 2, 3, 1, 2, 3, and 1, 2. And let's build some rail. Let's pull it over. Uh-oh. Okay, we're fine. I think that looks pretty cool. Actually, I don't. I think that would look cooler. And then we'll make a rail stop here. And we will set the destination. Ah. Our rail lines do not connect yet. Okay. Set origin to here. Steel bar 180. Okay. Excellent. Yeah, I believe that'll be all right for now. Okay, so we're creating 272 waste per minute. All right, so are these 3 sufficient? I think not. Okay, so our polymer production is sufficient. But for some reason, this factory is not receiving any polymer bars. And I think that is because we're finally
actually not able to produce enough polymer. Okay, so this looks like enough polymer. It's close. I think I'm gonna nip this problem in the bud and create a second pad. All right. Interesting. Let me see. Okay, so we've observed similar problems to this in the past. Okay, that seems better. It's not completely solved. Yeah, so I'm not able to pull everything off of a train. I am, oh, I see. I am observing that we are unable to supply a full train. Okay, we are unable to supply a full train from there. More pads helps until it doesn't. Okay, that should be sufficient for now. Okay, and we are limited. Steel bars are full because this is the steel sink. Okay. 2, 3, 4. Okay, so tomorrow I will come up with a method for offloading lots of items from trains because we are clearly unable to offload items quickly. Oh, you want me to increase the temperature by 30? Oh, that's gonna cause water though. Because then I'll be at negative 18. I feel like that'll barely cause a problem. Okay, so for now, I think that we can allow our city to crumble a bit. Yeah, I don't think it's necessary to feed the city our precious resources at this juncture. Okay, so that tap is shut off and this tap is now shut off. You can have your infinite resources and you can recycle your own waste back in, but you can't have any more concrete. Okay. So, yeah, so tomorrow we'll figure out how to load fast enough. I'm just gonna start off by making sure we have active miners on our patches. Okay,
And I guess it really is time to go to bed. I am very curious as to what the most efficient way to unload a rail stop, as to what is the most efficient way to unload a rail stop. So we're actually going to get rid of all of this. And I'm just gonna say that I know what that stop does. Okay, so let's change the destination to here, and let's change this one's destination to here. Okay, so I'm gonna quick save this. And then we're going to take a quick look at this. So we're gonna do it the hard way, quote unquote, to begin with. Okay, so this fluorite and sulfur. So we'll want 2 pads for each. So this can be fluorite, which is in the middle, and let's say that we have a symmetrical offload. This is sulfur, this is fluorite. Okay, so let's say we have sulfur here and here. Then we can feed 1, 2, 3, 4, 5, 6, 7. So I actually think these are the most likely to be active. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I think this is more than I had last time. So I think what I'm going to do is increase both of these to several hundred, and then see. Okay, so first of all, can I increase the loading speed by creating buffers? And the answer is kinda. And then the other question is, okay, so we can't offload the trains as fast as we can load them. So here's our sulfur. So we can also create an offload here and here and here and here. And then theoretically, we can have more machines active at once. So this is 14. Okay, so we're able to offload at max speed. So that's good. We are now, let's see. Yeah, we're now unable to load onto the train at max speed. So we'll move that there, and we'll put another friend there. Okay. 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 All right, so it does seem as though having tons of balancers at the end does increase throughput. And we're now limited on sulfur, and we're not at 100% machine usage. Okay, let's check some temperatures. Negative. Okay, so we're still highly negative. We don't even have the threat of water yet. I am quite interested in Neo Tokyo's development. So, what is our population? It's just hard stuck at 10,000. This is a funny thing that keeps happening in this game. Okay, and of course I'm being encouraged to create ice. Something that I do want is to coax this city down towards the Arctic. So I want to start building a wall around our fair city. So let's begin. So I think rail is a good thing to build around with. Okay, so I'm gonna pause the game. Rail is a very ugly thing to build around with, but what I can do is, you know, I can use my, no. Oh, actually, whoa. Okay, so if I don't want that, but let's say I'm okay with strips of road. With strips of highway next, or strips of okay. Okay, very fun. Okay, very cool. Okay. So I'm actually going to put the highways on the outside of these train tracks. Okay, so we preserve that little Dorito idea. Okay, so we'll put a roundabout here. Okay, so I think in general, cities prefer not to jump. Okay, so we'll continue along here. So I know from my past playthrough that that you can't force, you can't like actually, what's it called? You can't stop the city from growing. If you like try as you might, you will not succeed in stopping the city from growing entirely, but you can encourage the city to only grow in one direction, and that's what I want to do. So I want to coax the city south. So I'm going to build a corridor for the city to expand in. Actually, for science, I want to make this corridor as thin as possible. And because I'm impatient, nope. I'm going to destroy as much of the city as possible as well. Okay, so I'll build the rail on the inside of all of this. That looks very bad in my arrogant opinion. Okay, so we'll make this roundabout in here. Nope. What is the... So if I build... Okay, so what I want to do here is build a one porter and cancel... Okay, so for what it's worth, I don't think the city will expand into there. Okay, so for aesthetics, I'm not going to do too much more. So we're going to allow the city to expand this way. Well, who am I kidding? Okay. I can at least limit the number of tiles that the yeah, okay, I can limit the number of tiles that the houses have access to. I mean, this looks kind of neat. So it can grow like that. And I actually don't think that it can grow any other way. Okay. Oh, jeez. Underestimated the power of the city's like growth engine. I think it really wants to grow in a radius around Okay. So it seems as though it doesn't want to grow in this line that I've provided for it. How ungrateful. Okay, well, now the city is just limited and is no longer going to grow. Okay, so I am not sure that I want all of these when they're not strictly necessary. I think they lag the game. Those are fine. Okay. All right, so let me find our greenhouse gas generation. So, thank you. What was occurring here? The construction of rail infrastructure. 290 and 2,300 rails. I could see needing more rails. I don't need them now, though. However, I don't need them at the moment. Okay. So the fluorite is having difficulty getting to the station. Well, strictly speaking, that's not true. Yeah, okay. The fluorite. Oh, jeez. Oh, well, that'll do it. Okay, so the sulfur. Oh, so really we want to be like this. I want these to come over in this direction. Okay. I mean, it's not as though the problem is that we're running out of sulfur and fluorite. Although we are much closer. We are running every machine now. It's very close. Okay, so I know from experience that fluorite is not necessary, like as the game goes on. All right. Ice extractors, greenhouses, these are all quite simple. All right. So our next goal will be reaching a city to 100,000, I believe. I'm also a little bit discouraged by how difficult it appears to be to contain the city. So I think, I mean, there's no sense being shy about this. Huh. Yeah. So I'm not producing any, I'm not sending over any high speed parts or reinforced concrete. So in order to regrow this, I'm going to need to provide the city with, you know, the essentials. Oh yeah, but this is working. Okay. The city's creeping to the south. Okay. It's working. So we'll continue the zigzag. Okay. Okay, I think that lines up. Well-behaved city. So this city is stable up to 10,000. Oh. Wow. It is a good thing. Minus 1, 2, 3, 4. 1, 2, 3, 4. Minus 1. Alright. Ah. Okay. Huh. I wonder if I have my ratios right. Okay. So I don't see the harm in increasing the throughput. Yeah, it does sort of get out of hand. Okay. Okay, good. We have no filthy water yet. New Baghdad, you'll have your day in the sun. Okay. All right. It is. I will ask for more sulfur. I doubt that I will get it. 500. 1, 2, 3, 4, 5, 6, 7. So 10 times 30 is 300. And then after 10 we have 4 unaccounted for. So that's 420. So it is, I don't think that we are absolutely not mining 420 of this. So that'll mine, or the buffers of that will disappear. I think actually quite rapidly. Okay, well.
We certainly are moving at quite the clip now. But yeah, we are depleting our buffers. And these are not in range of their respective partner component. Alright. I haven't had to deal with water yet. I don't see a good reason that I will have to anytime soon. Okay, let's slow down our transport of essential materials. Okay, let's bring in one train. Okay. Alright. Reach a population of 1,000 in your second biggest city. Okay, well that is trivial. So let us I suppose delete everything. I don't know when I'm going to be asked to raise the temperature again, but when I am most likely going to want to start anew. Let us okay. I also suspect that when it does come time to build out some more infrastructure for like related things, I won't. Well, you know, let's take a quick look. Okay. We're at 1,000. So according to this, we are supply limited, and it's because we want reinforced concrete. Also, according to this, our city is 999, not 1,000. And I think that this city is, yes, the city is over 1,000, and this city is just in need of a little bit of reinforced concrete, which would come from here and, well, I suppose here and here. Okay, so let's make reinforced concrete. Okay, so we already have the plans for that. Yeah, no, that's right. Okay. Six, seven, eight, nine, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22. No, that's about it. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then minus. No, this is alright. Yeah. Yeah, this is enough. Okay. So then we make some factories. Specifically, we make 6 of them. We're gonna make steel bars, 2, 3, 4, 5, 6. And then we're going to make we're going to make 2 outputs. All right, and then we'll drag the rail line over here. All right. So Nouveau Baghdad coming right up. Okay. And then we'll have concrete and steel. Okay, so this one will be the concrete station. This one's actually closer. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 5, 6. Okay, 1, 2, 3, 4. Okay, and then we're gonna make sulfur production. So that's gonna be 1, 2, 3, 1, 2, 3, and then some concrete output. Okay, and then we'll make a train stop. And we'll set the destination here. No. Remove, and then we're going to okay. Nope. Okay. Let's set the destination here. Concrete. and we will set the origin of this here, and it will be steel. And then we will make concrete processing. Alright, factory 1, reinforced concrete, 2, 3, 4, 5, 6, and then our depot will reach here. That will be a reinforced concrete depot, and then our supply will be here. So we will. Okay. Okay, a total population of 30,000. Alright, so let's get rid of these. Alright, so we can. Well, we can reach a total population pretty easily by just increasing the population of one city. And then we'll get trees, and then it's like, yeah, I think, or I don't remember the rewards. Let me, Plan B Terraform Wiki. Okay. So, official release history, blah blah blah. So I want to see the. Yeah, you should have a freaking dope processor to play this game. This is the main page. No, here we go. What are these called? Level? Plan B Terraform. Okay, so we just need to reach 100,000. Yeah, this is fucking important. Okay, here we go. Okay, so total population 30,000, 100,000. Okay. So I need to cover 5% of the surface with forests. So that's going to happen eventually. So really I should be building towards that. So now the name of the game is water control. Yeah, so building water control and then raising the temperature very slowly, and then seeing how low of a temperature I can have while still growing pine trees. Because I just need 0 centigrade like along the equator. Or I'm not even, whatever the, yeah, so we're at max -14. So if I raise the global temperature to -14, then we can have pine trees. Because they'll be asleep all winter, but they'll spread. Yeah, so it's like, well, actually, we're in spring in the northern hemisphere. So theoretically, let's see. Okay, so at latitude, let's say 20, we're at -15 in the summer, and at -20, we're at -13. So it's actually this, there's actually a strip along centered at -19. Or no, it's like -20. So centered around -20 is the, I'll call it the, so it's 28 minus 13 is 15. So this is there's a -15 belt at -20 and probably at +20. Yeah. The belt is actually much wider at +20. So we will need some water, but it will be pretty freaking minimal and controllable. And since I'm playing on triple speed, there shouldn't be many other problems. So what I want to focus on is so I'm going to slowly raise the temperature and create trees. So we'll make a tree factory, we will not make any eucalyptus trees, and then we will then we'll boost the temperature and move from there.
starving, so time to eat. All right, I'm very happy with this. This is huge. Yeah, so like, well, I don't even have. Now I have to. Oh, this is what I'm working on for work. All right. Well, sleep well.